Page 5 starts out with rewriting in log form. So I start with 16 to the m equals n, and the log form of that is log base. The base of the exponent is the base of the log, so 16 of n equals m. And 16 and m can never be on the same side in both versions, so just always check and make sure that works out like that. Okay? And then this one is log base of the exponent is y, so log base y of x equals 18. Now if you ever have to convert and it says x equals y to the 18th, and you're like, oh, that kind of throws me off, then mark out the x equals and put it over here, and then you can work it that way, okay? Number 24 says evaluate without a calculator. So I'm basically using my power chart, which I don't have. Can I borrow one of y'all's power charts? Thank you, Caleb. Alright, so just so everyone knows, this is Caleb Johnson's. It says it right there.
Thank you.
No, I already said thank you, Eric. Okay, so 64, if I can rewrite this as, well, just a little background. If I have a base, like 3, right, and then it's log base 3 of 3 to some power, then that is just the power. Okay, so I can just cancel those out. In this case, if I can rewrite 64 as a power 4, then I can simplify it to just down that power. So I see that 4 cubed is 64, so this is log base 4 of 4 cubed, which means the answer is just 3. Number 25, the power is 1. So if I just simplify that out, I'm just left with a 1. Here, 81 is 3 to the 4th, but the answer is not 4 because then that would be no different from log base 3 of just 81, not 1 over 81. So I have to bring it up as a negative power. So it's log base 3 of 3 to the negative 4th, which means it is just negative 4. And then number 27. So I'm looking at all these, and 64 is 4 cubed, and 81 is 3 to the 4th, right?
Yeah.
Yep. So I look at 1, and I say, okay, 1 is 7 to the 0 power. So this is log base 7 of 7 to the 0 power, meaning this is just 0. Number 28, 64 is 8 squared. Over here, see that? So that is log base 8 of 8 to the negative 2 because it was in the denominator. And that leaves me with just a negative 2. And 81 is 9 squared, so log base 9 of 9 squared is just 2. And so those are my answers. Three, 1, negative 4, 0, negative 2, and 2. Alright, number 30 says to graph each function, identify the domain range, and draw and label the asymptote. So this is a logarithm function, which is the inverse of an exponent of an exponential function. So just as a little reminder, exponential functions look like this, log functions are going to look like that. Exponential functions have horizontal asymptotes, logarithmic functions have vertical asymptotes. Okay, so I know that this is, what I want you to do in order to graph these is go to your y equals, type it in, so y equals alpha window to do the log base 2 of x plus 2 and then minus 4, and I'm going to go to my table, second table, and I notice all these error messages, well, because I remember that logarithms, they have a vertical asymptote and they don't exist past that vertical asymptote. So the first error message you see is negative 2, and that is actually the vertical shift, or the horizontal shift left 2. So we're going left 2, and that is actually the first error message is your vertical asymptote. So that is a vertical asymptote at x equals negative 2, and you do need to draw and label it as a vertical asymptote and what the equation is. The next thing you want to do is plot points. So I'm going to plot after that. So negative 1 is at negative 4, 0 is at negative 3, 1 is at negative 2.415, so right around there. 2 is at negative 2. So I want the first point, the next 3, any whole numbers you see, 6 is negative 1, and then always the last point to see where you end the graph. So negative 0.67, which is somewhere in there. So if I look at the graph, just kidding. Okay, I'm going to go zoom 6, just do a standard window. If you look at the graph, you see something like this, and it actually does go past, negative 4, which is right around here. But people don't, let's see, yeah. You guys see that and you think, oh, well, that corresponds to this point right here, but it doesn't. It's actually right here. It can't show you, it doesn't have enough pixels to show you how close this is getting to that vertical asymptote. So what you have to do is just kind of go down and kind of draw along the vertical asymptote. So you have to draw that part, that tail of the graph. It does say identify the domain and range, so domain is left to right. The farthest to the left this function goes is negative 2, but we don't actually reach it, so we put a parenthesis, and it goes all the way to the right, so infinity. The range is up and down, and it goes all the way down to negative infinity and all the way up to positive infinity, but it takes a really long time to get there. Number 31 is natural log, which is just log base e. So you can either do log base e or you can just go to y equals and type in natural log, which is beside 4 right here. So natural log of x plus 4 and then plus 1. Go to the graph. I know I'm shifting to the left 4, so that should be the first, that should be actually the vertical asymptote. And if I go to the table, then I see that. So negative 4 is the first error message. That is in fact my vertical asymptote. So I'm going to draw a dotted line. My vertical asymptote at x equals negative 4. And as far as plotting points, I just take up from the graph. Negative 3 is at negative 1. Negative 2 is at 1.7. Negative 2 is at... No, just kidding. I did negative. Okay. Negative 3 is a positive 1. 1.6. 9, so 1.7 basically. So that's 1. Okay. 2.09, which is basically around 2. 2.38. 2.6. Okay. Yeah, well, that's what I said. So the first point 3 after it, any whole numbers you see, I don't see any, and then 8. 8 is 3.4. So around here. I do want to go ahead and I'm going to go ahead and plot at 4. It's basically at 3, so I'm going to go ahead and plot that just as a reference on where to go. So I'm going to connect those like that. And then I'm going to make sure to do the tail over here. So go to the vertical asymptote and then just go down it. So just kind of parallel along beside it. Alright, domain and range. Domain is left to right. The farthest left we go is negative 4. And then range is all the way up and all the way down. It goes down to negative infinity, goes up to positive infinity, so all real numbers. And the graph. The graph is part of your answer as well. And make sure you do all those. Okay. Number 32 has to do with geometric sequences. So, let's just go back over formulas for a minute. In explicit, formula is a sub n equals a sub 1 times r to the n minus 1, where a sub 1 is the first term, and r is the common ratio. Not ration, ratio. And we find r by always taking the second term and dividing it by the first, or the third term and dividing it by the second. So any term divided by its previous term, and that should be r. Okay? Now that's the explicit formula. The recursive That's explicit. You're defined by the number of terms, your first term, and the common ratio. Recursive, you're defined in terms of the previous term. So a sub n equals a sub n minus 1 times my rate. And then you always have to state what the first term is. So that is definitely, that is part of your formula, so you have to do that. So number 32, which is 32 when you can't talk, it says determine if it's geometric. So first, I'm going to say, okay, the second term divided by the first. Negative 9 divided by 3 is negative 3. 27, the third divided by the second. 27 divided by negative 9 is negative 3. And negative 81 divided by 27 is negative 3. So because those are all the same ratios, I know that this is a geometric sequence. So it says find the explicit formula, the recursive formula, and a sub 9. So first let's do explicit. A sub n equals a sub 1, which is the first term, times the rate, which we found to be negative 3. So I'm going to put that in parentheses. Raised to the n minus 1. And so my formula, everything in pink is what's always there. We fill in the first term and the common ratio. All right. Now, for the recursive, a sub n equals a sub n minus 1 times the common ratio, which is negative 3. And then you have to state what the first term is. So these are two different answers. And for the recursive, you have to state both the equation and the first term in order to get full credit for that. And then it says find a sub 9. So a sub 9, the easiest way to do that is to use the explicit formula. So we've got 3 times a negative 3. I'm going to use another color for this. A sub 9, and then we say to the 9 minus 1. So I'm just filling in 9 for n. So I'm really just saying 3 times negative 3 to the 8th power. So 3 times negative 3 to the 8th power. And that is 19,683. On number 33, I need to find the common ratio. We good? No questions? Okay. Okay, so 4 divided by 1 is 4, 16 divided by 4 is 4, and 64 divided by 4 is 4. So my common ratio is 4. My explicit formula, a sub n equals, oh, yeah, no I didn't, okay. A sub n equals the first term, which is 1. One times, now the common ratio is 4. I put parentheses around negative 3 earlier because it was a negative, but I don't need it when it's just a number. If you want to put parentheses, you can. To the n minus 1. A lot of pens in my hand. Okay, so that's the explicit formula. And then the recursive formula is a sub n minus 1 equals a sub, oh, that's wrong. A sub n equals a sub n minus 1 times my common ratio, 4. And then I have to remember to state that a sub 1 equals 1. And then the last thing I want to do is find a sub 10. So a sub 10 equals, now remember, you could just go ahead and keep going and just keep multiplying by 10. This is the fourth term and just the 6, 7, 8, 9, 10. But you can also just use the recursive formula. So I've got 1 times 4 to the 10 minus 1. And so that is going to be 1 times 4 to the 9th, or just 1 times 4 raised to the 9th. And that is 262,144. got the explicit, the recursive, and a sub 10 equals that. The explicit, the recursive, and a sub 9. Alright, number 34 says given the explicit formula, find the recursive formula, the first 5 terms, and the term named in the problem. So, the recursive formula, well, first I have to make sure I know what I'm looking at. Negative 2 is my, so looking at the formula, first term, so that's a sub 1, and negative 4 is the common ratio. So, as far as my recursive formula goes, a sub n equals a sub n minus 1 times my common ratio, which is negative 4. Bye. And my first term is negative 2. So then I just say that. And there's my formula. It says to find the first 5 terms. So I'm going to go ahead and list 1, 2, 3, 4, 5. A sub 1, 2, 3, 4, and 5. My first term is negative 2. And then you multiply by a negative 4. And you get a positive 8. And then we multiply by a negative 4 again, and we get a negative 32, and by a negative 4 again, and you get 128, and by a negative 4 again, and you get 512 negative. So there's my first 5 terms. And then it says find the 9th term, so I could just keep on going with that, but I'm going to go ahead and use this formula, the original formula, the explicit. A sub 9 equals negative 2 times negative 4 to the 9 minus 1. And that is just, yes, negative 2 times negative 4 raised to the 8th. So negative 131,072, and there we go. So I've got the recursive formula, the 9th term, and the first 5. So always make sure that you read the directions and you're filling in everything that you need to. And that is page 5.